So we started 10.5 yesterday. Apply other angle relationships in circles. So we said if a chord and a tangent intersect at the circle, that the angles formed would be 1/2 the arc. We said if we've got these floating angles, or the angles in which their vertex is not on the circle or not in the center, then we add the arc it intercepts plus the arc its vertical angle intercepts and divide by 2. And then this one, which is either 2 secants, 2 tangents, or a secant and a tangent. And for these, we would say that meet outside the circle. For these, we would say the big arc minus the little arc divided by 2, or big arc minus the little arc times 1/2. This is where we left off. Okay, so it says UT, and that should be an is tangent to the circle. So here, this would be a tangent line here. So that means what about where? Well, let's go first. Let's go through what it says. That one says it's the tangent, right? And then it gives you that arc. WR is 110. It gives you that arc. ST is 100 degrees. And then it gives you that angle U over here is 30 degrees. So those are the piece of information that you have. So angle U is formed by a secant, in this case a secant segment, right? And a tangent segment, which is outside the circle. So if I want to find UT, that's the first thing that we're looking for. I want to find arc UT here. How do I find it? So how would I have typically found angle U? Because it's outside the circle. So go back a slide. Big arc minus little arc divided by 2. Okay, this time I know the angle. I'm missing one of the arcs, but the same formula still works, right? The big arc minus the little arc divided by 2 still equals the outside angle. So the big arc is 100. The little arc is what we don't know. Divide it by 2 and it equals the outside angle, which is 30 degrees. Everybody see that? Yeah. So then I would solve this by multiplying by 2 on both sides. It's going to cancel from the left. 100 minus x would equal 60. Subtract the 100. Negative x would equal negative 40. Multiply or divide by negative 1, and x is 40. So now I know the measure of that arc. Questions so far? Okay, then B says find the measure of angle TVS. So is TVS a central angle? Is it an inscribed angle? What's inscribed mean? Inscribed means the angle is on, the vertex is on the circle. So is TVS inscribed? No, so it's that third kind, that's that floating angle in between. So to find the measure of that angle, I do what? Good. Add the arc it intercepts plus the arc its vertical angle intercepts and divide by 2. So TVS intercepts 100 degrees. Its vertical angle, which is opposite it on the other side, intercepts 110. So I add those two and divide by 2. I get 210 divided by 2, or multiplying by 1/2, same thing, and I get 105. God bless you. Alexis.
So would be the angle, the little angle V, would that be congruent to?
Which V? R, V, W?
Yeah.
Yeah, they're still vertical angles. So the vertical angles are still congruent even if they're inside the triangle. Inside the circle. All right, the next one is the measure of angle RVS. So RVS is this angle here.
Is it just 80?
Not 80.
180?
Nope. So that one and the 105 add up to 180. That you could do it that way. This would make it what? 75. Anybody see another way to do it? Okay, so wait, not the 110 by 2 though, because it's not inscribed. You'd get the same thing on the other side. This is 105, right? So you'd still subtract. from 180. But how do I find it using its arcs? How do I find a floating angle using the arcs? Right.
You add 110, 40, and 100, and then subtract that from 360 and measure the big arc.
Good. So if I added up the 3 arcs that I have, I get 250. Subtract that from 360. And I get that this is 110 degrees. That's the only piece of the arc or piece of the circle that's missing. You with me so far? And then if I wanted to find the angle that was in here, this angle in here, good. Add 110 and 40 and divide by 2. The angle, it's vertical, the arc, it's vertical angle intercepts. So if it's a floating angle, it's the arc it intercepts plus its vertical angle divided by 2. So everything you know about lines still applies to circles. Everything you know to the chords. Everything you know about vertical angles still applies to the angles formed inside the circle. Okay? All that stuff still applies. So now we found angle RVS was 75 degrees, and we found arc S was 110 degrees. Questions so far? So obviously these diagrams are going to start to get a little bit more complex. You got to figure out what you're looking at. All right, example 2 says if the measure of arc AB is 105, so this one is 105, find the measure of angle D. So D is located where? Inside, on, or outside the circle? Outside, which means I would use which of those little formulas to figure it out? Big minus little divided by 2. Good.
The other side is 180.
How do you know what the other side is?
The semicircle.
That would give you, oh, this, you mean this here is 180? Yeah, you could look at it that way. You're still missing the other part of the arc, though, because the big arc in this one is all the way around from A to C to B.
So it would be 180 and then subtract 105, that's what that.
Okay, which would be 75, right? And then add them all together. 250. Okay, or I could have done 360 minus 105 and gotten it that way too. Again, either way, all that stuff still applies, it still makes sense. So if that's the case, then I would do 255 minus 105 divided by 2. So I get 150, wow. 150 divided by 2, which is 75 degrees. Questions on that one? So the only time you can do that, like if you only have one arc on a circle and you're trying to find the outside angle, you don't have that either. The only time you're going to be able to do that is if it's 2 tangents. Because 2 tangents are going to hit that circle, and then the rest of it can be found by 360 minus that one arc. It's the only time it works. All right, arc AB this time. Again, I have an angle formed, and it's located where? Outside, which means I'm going to use big minus little divided by 2 equals the angle. This time I have the angle and I'm missing which one? The big arc. So let's say this is x minus the little one, which is 20, divided by 2 would equal the angle, which is 10. Multiply by 2 on both sides. X minus 20 equals 20. Add the 20. And x is 40 degrees. So you've got to figure out, based on where the angle is located, which equation or which expression you're going to use to find the measure of it. Questions so far? Okay, so a quick recap. All right, so the first kind of angle we talked about was a central angle. I would have my vertex on the center. And if I asked you for the measure of angle 1, you'd tell me it equals what?
Half the arc.
Not half. So central angle is what? Is equal to the arc. Okay, so that's the differentiation. So this is a central angle. And this time it equals the arc. So let's say this is 60 degrees, and arc 1, or angle 1 would equal 60 degrees, and vice versa. If I have the angle, it would equal the arc. Then we talked about inscribed angles. And this time, what's true about the measure of that angle? It's half the arc. Good. So again, if the arc was 60, let's say, then angle 1 would equal 30. And vice versa. If I have the angle, I double it to get to the arc. Good so far? Yeah? Okay, then we had a tangent and a chord. What's true about angle 1? It's half the arc. So let's say this arc is 100, angle 1 would be 50. So a tangent and a chord and an inscribed angle are both half the arc. Okay, then we had the little floating angle. So this is an angle in which its vertex is not on the circle and not in the center. How do I find these? Good. Arc it intercepts plus the arc its vertical angle intercepts divided by 2. So let's say this was 60 and this was 40. I would do 60 plus 40 divided by 2, or 100 divided by 2, which is 50 degrees. Questions on that one?
You say 1 equals 50?
Angle 1 would equal 50, yep. And then the last 3 were if I had 2 secants, a secant and a tangent, or 2 tangents. And for each of these, with these angles outside the circle, I use exactly the same thing, which is what? Good. Big minus little. Divided by 2 is going to give me the outside angle. So whether I have the angle in one of the arcs, or I have both arcs and not the angle, or on the tangents, I can have one arc, then I can find the rest of it.
They always have to give you one of the arcs.
They have to give you, with the tangents, you have to either have the angle or one of the arcs. With everything else, you have to have 2 of the 3.